Now let's look at some IB exam problem about application of exponential functions. Initially, a tank contains 10,000 liters of liquid. At the time t equals 0 minutes, a tap is open, and liquid then follows out of the tank. The volume of liquid V liters, which remains in the tank after t minutes, is given by this formula. A. Find the value of V after 5 minutes. For A part, we got the V equals 10,000 times 0.933 t power. We know t equals 5, so we plug in. You will get 10,000 times 0.933 to the 5th power. Put into calculator, you will get 7,069.82 liters left after 5 minutes. For B, find how long to the nearest second it takes for half of the initial amount of liquid to follow out of the tank. In other words, for V equals 10,000 times 0.933 to the tth power. We know this V will be 5,000 equals 10,000 times 0.933 to the tth power. So we solve this equation first. We divide by 10,000 both sides. Then we got 0.933 to the tth power equals 0.5. Then we do the log both sides. Base is 0.933. So we got t equals, put into calculator, you will get t will be 9.995 minutes, but we need to turn into seconds, so we multiply by 60. You will get the t equals 600 seconds. Now let's go to C. The tank is regarded as effectively empty when 90% of liquid has flowed out. Show that it takes almost 3/4 of an hour for this to happen. For this formula, V equals 10,000, 0.933 to the tth power. Since this V means the remaining liquid, that means when 95% of the liquid has flowed out, means only 5% left. So for this V, you will get the 5% times 10,000. That's the V equals 10,000 times 0.933 to the tth power. Still, we need to divide by this 10,000 both sides. You will get 0.05 equal 0.933 to the tth power. Then we do the log base 0.933 both sides. And you will get the t equals. We put this into the calculator. You will get the 43.20 minute. As we know, 3/4 of an hour means 3/4 times 60 minutes. That means 45 minutes. In other words, we figure out t equals 43.20 minutes. We proved that almost take 3/4 of an hour for this to happen. Now let's go to this D. Find the value of 10,000 minus V when t equals 0.001 minute. We know V equals 10,000 times 0.933 to the t's power. We plug in that 0.933 to the 0.001 power. You will get 9,999.31 liters. We're looking for 10,000 minus V. That means 10,000 minus this value. You will get, answer will be 0.69. This is for first question of D. Second question, hence or otherwise estimate the initial flow rate of a liquid. As we know, the initial flow rate of a liquid R equals original 10,000 minus V over the time. Then we plug in here 0.69 over 0.001. You will get 690. That will be liters of a minute.